April 26th, 1986, 1:23 a.m. It's a date and time stamped into the history of the world, isn't it?
Absolutely. It's the moment the worst nuclear disaster in human history began. But the terrifying thing is, if you were standing a few miles away from the Chernobyl power plant at that exact second, you wouldn't have heard a war breaking out. You wouldn't have seen an enemy army.
Right. It was quiet.
Deadly quiet. But an invisible enemy radiation was already escaping. It changed the map of Europe, it displaced hundreds of thousands of people, and honestly, it completely rewrote the rulebook on industrial safety.
And that's what we're digging into today, because usually when people talk about Chernobyl, they talk about the explosion, the radiation burns, the horror movie aspect of it. But looking at the research, the real story seems to be about something much more mundane but equally deadly: human decision-making.
Exactly. It wasn't just a machine breaking, it was a system failing.
Let's start with the machine itself. Reactor number 4. What are we dealing with here?
So, this was an RBMK 1000 reactor. In the Soviet Union at the time, this was the pride of the fleet. It was massive, graphite moderated, and water cooled. On paper, it was a beast. It was designed to produce huge amounts of electricity and, crucially, plutonium. It was powerful and efficient.
But
it was unforgiving. It had a critical design flaw that Western reactors didn't have. It lacked a full containment building. Basically, if something went wrong inside, there was no giant concrete dome to keep the bad stuff in. It was like driving a Formula One car without a roll cage.
that sounds incredibly risky, and yet the disaster didn't happen during normal operations, right? This is the part that always blows my mind. It happened during a safety test.
That is the ultimate irony of Chernobyl. The disaster was caused by a test designed to improve safety. They wanted to see if the reactor's spinning turbines could generate enough residual power to keep the cooling pumps running in the event of a blackout.
So, trying to prevent a meltdown caused a meltdown.
Precisely. And this is where we get into the human element. To run this test, the conditions had to be very specific, but everything that could go wrong did go wrong before the test even started. The reactor power had been forced too low, making it unstable.
And the operators knew this?
They suspected it. But here is the key: schedule pressure. They had a deadline. The grid controller in Kyiv had delayed the test, so by the time they were ready, it was the night shift. These guys were tired, and they were under immense pressure to just get it done.
That's a dynamic anyone in any industry can relate to. Don't ask questions, just meet the deadline.
Right, and to meet that deadline, they started disabling safety systems. They pulled out the control rods, which are like the brakes of the reactor, way beyond the safe limits. They effectively stripped away the car's brakes to make it go faster, just to finish the test.
Because the culture didn't allow them to say, "Stop, this is dangerous."
Exactly. In that environment, questioning authority wasn't just discouraged, it could end your career. So you have a culture of silence meeting a technically unstable machine.
So take us to 1:23 and 40 seconds AM. The test is happening. They realize something is wrong.
The power starts surging. The operators realize they've lost control. So Akimov, the shift supervisor, presses the AZ5 button.
The emergency shutdown. The panic button.
It should have been the savior. It drives all the control rods back into the core to kill the reaction instantly. But this is where the design flaw I mentioned earlier comes in. The control rods were made of boron, which absorbs neutrons and slows things down. But the tips of the rods were made of graphite.
And graphite does what?
Graphite accelerates the reaction. So for a split second, as those rods entered the core, they didn't slow it down, they spiked the power.
It's like stepping on the brake and having the car accelerate to max speed for a second before stopping.
A perfect analogy. But in a nuclear reactor, you don't have a second. The power surged to catastrophic levels instantly. The fuel channels ruptured, the water turned to steam, and boom, the 1,000-ton lid of the reactor was blown right off.
And just like that, the core is open to the sky.
The graphite caught fire. And that smoke, that was radioactive fuel going straight into the atmosphere, no filter.
The immediate aftermath is heartbreaking. The firefighters arriving, they didn't even know what they were fighting, did they?
No idea. They arrived in standard gear. No radiation suits. Some of them were literally picking up pieces of burning graphite with their hands, not realizing they were holding pieces of a nuclear core. They were dead men walking the moment they arrived.
It's tragic. But I want to pivot back to the why. We talked about the button and the graphite tips, but you mentioned earlier that this was a system failure. It feels like blaming the operators is too easy.
It is too easy, and for a long time, that was the official Soviet narrative. Incompetent workers. But the root cause was much deeper. It was a lack of safety culture. The operators didn't know about the graphite tip flaw because that information was classified. The designers knew, but they didn't tell the people running the machine.
That is terrifying. The people at the controls were flying blind because of secrecy?
Yes. And on top of that, you had a culture where production was valued over protection. If you raised a safety concern, you were a problem. If you met the quota, you were a hero. That creates a psychological trap where smart people make fatal decisions because they are more afraid of their boss than they are of the physics.
That resonates so hard today. I mean, look at software engineering, oil and gas, even finance. How often do we see disasters because someone was afraid to say, hey, this code isn't ready, or this pipeline looks rusty?
It's the universal lesson of Chernobyl. It applies to chemical plants, refineries, even AI development today. Wherever you have high energy or high complexity, you have risk. And if your culture punishes transparency, you are engineering your own disaster.
So, if we look at the legacy of this, obviously, we have the exclusion zone, the ghost city of Pripyat frozen in time. But what did the industry actually learn? Did we change?
We did. The biggest shift was in transparency and human factors engineering. Now, you don't just design a system that works when everything goes right. You design a system that remains safe, even when the human makes a mistake.
You assume the operator will have a bad day.
Exactly. You assume they are tired, stressed, or confused, and you build safeguards that don't allow them to bypass the safety protocols. You can't just turn off the safety systems in a modern plant the way they did at Chernobyl.
And I suppose the other lesson is about voice.
100%. Stop work authority. In a healthy safety culture, the lowest ranking employee should have the power to stop the entire operation if they see something unsafe without fear of being fired. If the operators at Chernobyl felt safe enough to say, no, we are not running this test tonight, the world would be a different place.
It's heavy to think about. We paid a massive price for that lesson.
We did. The radiation spread across Ukraine, Belarus, all the way to Scandinavia. We're still seeing higher cancer rates. The cost was generational.
As we wrap up, it feels like the takeaway here isn't really about nuclear physics. It's about organizational psychology.
That's the best way to put it. Chernobyl wasn't caused by ignorance alone. It was caused by arrogance, silence, and pressure. Technology failed, yes, but the culture failed first.
It reminds me of that idea that bad news doesn't get better with time. It just gets deadlier.
Ideally, if this story makes even one manager listen to a concern, or one engineer say, wait, stop, this isn't safe, then remembering Chernobyl is worth it.
A sobering but necessary discussion. Thanks for breaking this down with me.
Anytime. It's a history we can't afford to forget.